Isn't it like sickly sweet?
I think it.
Yeah, no, I don't
It's
like it.
So, speaking of the rest of our time here in the second 9 weeks, we are up against the weekend. This is our last lesson for the second 9 weeks, as well as our last lesson for our test cycle here. So what's up next week? We've got our exam week next week. On Monday, we have 1 and 3 exams. If your teacher gives you a test or an exam that is not on their day, you need to narc them out. Okay? You've got to rat them out, all right? Because we're not supposed to do that. It is for your own peace of mind and protection of your mental states.
It's already bad.
Okay?
They're thinking about that?
So,
You can't control that one. That one's gone.
if you get a test which is not your day, so like if your 2A gives you a test on Monday, that is not
Oh,
allowed.
you know I'm gonna rat her out.
Pressure on you guys. You gotta tell an admin.
Miss Lee.
Take it though.
We lost her.
Take
Is
it.
What
it
if you
Mandarin
wanna
teacher?
take it?
I thought we only have 2 classes
I
per
want to
day.
take all the tests that on one day.
I thought it was just
Mr.
Okay, that's
long
just
classes.
No.
I just gotta go to every period.
Yo, it was
You
Jim.
can't have some.
I thought I'd have to go to each period.
They gave me 3 tests in the same exact
That's why I was
day.
confused. I was like,
And they were all
I don't even go to
my
those
hardest
periods.
classes because I had like all my hardest classes on one day. And I handed all
For my hardest classes,
Like,
was
back, back,
definitely
back.
this class and AP.
I know I'm failing this
Like,
class.
It's just this class and AP.
I don't need all that.
It might just be this class and AP.
Exactly.
Spanish.
Anywho, so on Monday, we are not testing because it's not our day. Our day will be Friday. So next Friday is our semester exam. We'll have a lab on Monday. On Wednesday, technically there is no exams because it's Wellness Wednesday. We have shorter classes. I did schedule our last chapter tests on that Wednesday. Now, typically, I don't like to do like back-to-back exams and tests and stuff because it's hard on you guys. So, in the case that you wanted to take this particular test, because we only have 2 tests on the book, I typically like to do 3 or more during a quarter. So, I'm going to call this test optional. Okay. As in, you have the option to take it or not take it on Wednesday. I will even
On Wednesday.
extend the options to even if you do take it, if you do poorly on it, I'll just pretend like it never even happened.
This is why you're the favorite.
Make it disappear. You'll make it disappear.
I'm just gonna take it. I'm just gonna take it.
That's what we do at Christmas.
He'll make it disappear, dude.
Can y'all be so proud of me?
Why?
I told you my score. I'm so proud of myself. I got a 40 something on the last test. That's the highest I've ever been in my life.
So, completely optional test on Wednesday.
Going from 15 to 40 something.
If you don't take it, then we'll just have more time to work on your egg job project.
Let's have a
something like
party.
that. Okay? Which is coming the next week.
Of course it is.
So on Tuesday, you will have a work day. So you'll have all class period to work on your head job projects. And then on Thursday is when it all comes crashing
We
down.
don't have this class.
Hopefully safely.
Like my mentor.
Yes.
Next
Yes.
week.
We do have it Tuesday. Or not. Yeah, next week is Tuesday.
Oh, I see a bubble wrap.
2 weeks.
No more punch.
I assure you.
So you're gonna do it by yourself?
What?
You're gonna do it by yourself?
Wait, I'm not broke. I can buy materials. I swear I can. Oh wait, do we have
I
to?
also, fun fact, this year I moved into a new house and it has like a second story. First time ever living in a second story, but I still have a thing that I can practice.
That's good. That's good.
3-story.
You live in a 3-story.
So the file, including things that you
I had a
possibly
friend. She had an elevator in her house.
cannot use is in
I could stand her.
Yeah. I had this one friend who I hate her now, but she
always
she's got a 3-story house and she had a 2-story garage.
Garage? Like
She would persist that she's not rich.
Stop that.
And when I asked her, like, we were just talking, and she was like, I just want you to know that I'm not rich, I'm very wealthy.
In fact, I'm gonna go up to
You want to know something?
We're not friends anymore.
and drop them on
Yeah.
the side.
My friend had an elevator in her house.
also the elevator. That shit pissed me off.
Pissed me off.
I just stood in there until
You can't use your
Like,
legs.
what the fuck?
Hold on, guys, hold on.
You're that lazy that you need to stay in that elevator.
It was for a mental.
Bless you.
So we talked about our field trip. It is completely done in terms of payments. So if you weren't able to pay by Tuesday, I still need your permission slip. I also need some t-shirt sizes from some of you, although I don't think that we'll have enough money for t-shirts, but we'll see what happens. So that's that. So make sure I get those permission slips in as soon as you can. And yeah, I think that's it for our announcements. Any other questions concerning general things? Yes.
Since the Unit 4 test is optional, will there not be a study guide given out for it?
Oh, we do have a study guide that you'll get today. In fact, Tracy, if you want to go ahead and pass these out, that'd be grand.
Gracias.
I actually studied for this, so I don't have to
It
guess.
can get bigger if people do worse in the semester exam.
I will apply the typical AP curve on the exam, and if necessary, some additional points.
What is the typical curve?
I posted a picture of it
Go.
in
He's just a
Reddit.
legend.
It's like in the very beginning.
I love him just hitting class.
Yes.
Yo, both, bro. You can't fit. You can't fit.
Good.
If you fit, you're good.
Okay, let's take a look at our Bell work question here. Talking more about oscillations. Shouldn't take too long. So checking out your answers, getting teams on the phone, switching classes for A. Somebody's at the door. Somebody's poisoning the water.
Let me try to answer the first one, right? A point 40 kg mass is going to be concentration.
Mr. Mater, do you
What is
have
a maximum
extra LED lights on broken?
Okay, so maximum acceleration system. So we know
My
it goes
eyes
with a
Poison
spring.
the water.
So we know it's going to be force equals K.
Yep.
It's a spring constant.
Wait, say that again?
So then,
Somebody's
yeah,
poisoned the water
so
bowl.
that
That's,
equals 12
I know what that is.
times.
I swear I know what that is.
Now,
It's Toy Story. Toy Story.
Toy Story. Who says it?
One of the
It's one of the things that he says when
It's how you said it.
Do I get T points? Do I get T points?
Wait, what's the joke? Yeah, what's the joke?
Yeah, where my T points at? I just answered that.
My apologies.
Where's the diagram?
It's a question, this one.
yeah.
What do you get when you tell food jokes?
Oh, mouth
You get
full of-
a very cheesy life.
Wait, what is it?
That's not bad, but that's
Something
not
corny?
the answer.
Wait, what's it?
What do you get when you tell food jokes?
A mouthful.
A mouthful of cheese.
Belly laughs. I get it.
That wasn't very good.
That was awful. I like my answer better.
Last class was a simple one. I remember. It was really
I'm
easy.
one for dad jokes, but that one was
I don't know
not
what that
even
means.
close.
Yeah, I know.
They haven't been hitting quarter one
I
down
think,
jokes.
All right, here we go. Let's take a look
I
here.
think
I'm gonna
the
call that
something
done
cheesy
because you
was
had
funny.
way too much time. Our question asks if the amplitude of a system moving in simple harmonic motion is doubled. So if the amplitude is doubled, let's shorten it, okay? Which of these doesn't change? And most of you said D. I did have one B in there. So if we look at D, which is the most popular answer, recall that we had two equations for the period, one for the mass on a spring, the other one for a pendulum. If we were to look at those equations real quick like, we have the mass on a spring, and we have the period of a pendulum. And in neither one of them contains something that can be construed as amplitude. So there's no x, there's no a, there's nothing that says displacement here. So the amplitude doesn't actually affect the period. So it doesn't matter if we double it or triple it or halve it. It doesn't matter. It doesn't affect the period at all. Remember, we talked about how over time, the amplitude actually decreases because of air resistance, which would be a reflection of the energy. So it loses energy as time passes due to those resistive forces, but it doesn't change the time, the period for the oscillation or the frequency. Both cases, they don't change if we're oscillating more or less. The time is still the same. So D is the correct answer. Okay.
More points.
All right. So let's give you the points that you just earned.
That's flat.
Yeah.
It said not me, real Jordan.
What's that?
We're the richest table, though.
Oh, I'd have to tally it up, but actually I'm on the wrong page.
No, quarter 4 test.
At first
I might get
glance,
100.
it's gonna be probably quantum.
What's quantum?
Right here, bro. Yo.
Who's second?
Can we just give
Not
Xavier?
us.
Just give Xavier his
Second
own
looks
desk.
like spectrum.
This ain't fair.
Boo.
Who named they stuff?
They beat Farby the second.
All right.
The
So let's,
worst,
let's-
the worst company of all time.
No, it's because they always pick second and third. They go right after us. They just put after us. They always put it right after us.
Copy y'all's answers.
Yeah, that's
Alright, let's see.
Are you ready
Each
to
of us is putting our own
wonder
answers.
which Jack number?
No.
Alright, you go check this.
I'm not gonna lie. Remember that one 16-point class?
Dude, my knee hurts. I don't know.
I haven't hit that.
We got spectrum,
That one 16-point class.
up and atoms.
I'm not actually.
My bad.
Never mind, guys.
You can look at
This
behind
test
I was-
score might not
I was
be
I'm
as
actually
high
so
as
happy in my life.
Twice, Rashawn. I don't
Oh,
know
so
why.
sad. I'm not-
Boost us up like
Weird.
Oh, is it
a
because
single
Okay,
percentage.
Here we go. So, if you actually read the pages in your book,
I did,
you might
I did.
notice that this section has green sides on it that says HL only.
Higher
Now,
level.
you are correct.
So I didn't need
Okay.
it.
Now, the reason why we're learning this now, before you even choose to go SL or HL, assuming that you do continue with IB physics, which we'll talk more about in February and March when you're actually picking your classes for next year. But we are learning this stuff because it's required for the AP exam that we're taking this year. Okay. But in the future, if you choose to continue with IB physics and you go SL and not HL, these sections will not be required for you later on. So that's the idea, is that yes, we will learn it now, but you just don't have to review it later when we're studying for the IB exams at the end of next year. Cool. Okie dokie. Well, let's jump in now. Because this is HL material and HL equations. Notice on our equation sheets, our booklets here, we have our C1, which we've been talking about for the last couple of days, but then there's another C1 at the bottom of the page with additional higher level. This is where this lesson comes from. Okay, so all of the equations that we'll talk about today come from that additional higher level, or AHL, C1 section at the bottom of the page. Okay? Cool. So, last class we talked about and we saw that that if we hooked up the motion sensor, we saw like there was a position time graph and the velocity time graph and the acceleration time graph, and we identified that that the position time graph looked like a cosine curve. Okay, which there was an assumption there. That's dead, Jim. Here we go.
Hole in one. Oh yeah.
I don't think I can do that at varsity.
Feeling good. Feeling good. Here we go. Okay. You can't see that. So.
You're a poor expert.
There you go. So, we saw last class that our position as a function of time was more like a cosine curve, okay? Some sort of cosine as a function of t. We also saw that the velocity time graph looked more like a negative sine curve, okay? And there was an assumption here. We assumed that at the time of 0, when I start my stopwatch, okay, or when I start collecting on the motion sensor app here, I'm assuming that we're starting at the amplitude, at maximum displacement, okay? But let's say that I start my motion here and I click Start Collecting Data button. It could start at any part of the cycle, technically. It could, okay? Now, if you look at your equations though, let's take a look at our first one, the position as a function of time. That first one, that x, well, it says sine and not cosine. There's a reason for that. I'll tell you that in just a minute. So we are going to not really scrap what we talked about last class, but it's going to be a little different when we talk about it for this class. So here we've got our position function. Now it says, and we're going to identify the pieces here. So we got x is equal to x naught. That's going to be our amplitude. Okay, naught usually means initial, and this is going to be our initial position, or in this case, maximum position, which kind of makes sense because as I pull my mass on a spring, I'm going to give it the initial displacement that I give it. That happens to be the maximum displacement as I let it go, as it oscillates. It's always going to meet or it's never going to go further than what I gave it initially, right? It's not going to gain energy as a result of the oscillation unless there's some other weird resonance force happening, which is possible, but we're going to ignore that for right now, okay? So this is going to be our amplitude. So as we continue with our equation, where did it go? So we got sine, so here's our sine function, and inside we have omega t. So remember that was our angular frequency, okay, for our time t. And then our phi, not sure if I talked about this before or not, but this is our phase difference, or our phase constant, okay? So this basically shifts the graph left and right, based on if it's plus or minus and how much it is, okay? In fact, I might have mentioned before, or last class, how the sine and the cosine curve are really the same curve, just shifted. There's a phase difference. In fact, there's a phase difference of exactly a quarter of a period between the sine and the cosine. So when we look at this, this is our equation officially that they give us, and we know that it's a sine function. So if it's a sine function, and we know that our phase difference is 0, so that it's exactly a sine function. If I were to plug in sine of x into my calculator, I'm going to get a graph that looks like that. So remember that we made an assumption last class that the graphs that we looked at were assuming that we were starting, the timer was starting when we were at the amplitude. In this case, when the timer starts, where are we?
0.
At the equilibrium point, where x is 0. Exactly. So the equations that we talked about last class were correct because we defined where we're starting from. This time, we're just defining the starting point at a different location. In this case, we're starting at the amplitude, as in, if I were to start this motion and I were to time it just right, where I start my data collecting right as it passes through the equilibrium point, then I would get this type of graph and this type of equation, okay? So in most cases, our phase difference here will just be 0, but we have to look at when it starts. If it says specifically the time starts when it passes through equilibrium, then this is the straight up sine function, and we don't have a phase difference at all. This is just 0. Okay? Cool. All right. So likewise, we have a velocity versus time equation here. Notice that there is an extra bit, so it's not just the amplitude, but it's the angular frequency times the amplitude. And this really comes from, although you don't know calculus yet, because some of you guys are pre-calculus, that's not the same thing, but using calculus, going from a position to a velocity, you're going to take the derivative or find the slope of the graph there. And the derivative of sine is cosine, okay? But whenever we take a derivative of a inside function, because there's two things that are happening here, a piece of the inside pops out in front of the function. That's just how the derivatives work, which you'll learn about someday, okay? By the way, if you ever need any help in calculus, I'm your guy. No, I can't teach it. I mean, technically I could teach it because I know the material, but I'm not, yes, I'm not certified to teach it. So technically, I could teach out of field for 1 year, but no more than that, so.
Would you teach calculus or
Like if I had a choice? Oh, physics. But if I had my super choice, I would teach calculus-based physics.
That's not
Which is, so if you didn't know, there are two versions of physics that you can take in high school and in college. There's algebra-based physics, which is what we do here, and then there's calculus-based physics, which is the AP Physics C classes. If you've ever seen that, there is an AP Calculus-based physics course. I have taught it in the past. It's been a few years because usually not a whole lot of people like to take it, but oh my gosh, I completely geek out in that class, just because Sir Isaac Newton, who did a lot of the physics stuff that we are learning about now, he invented calculus too, in order to do physics. So when you learn it together, like you see how the equations actually all connect to each other. Awesome.
Do you teach it in Ivy?
I choose life. I have a question.
Yes.
So if I pull up in here after school on a Tuesday with my calculus homework,
I'm your guy.
I'll
Dang.
see you on Tuesday.
All right.
I'm about to be like, oh yeah, I need help with this one too. 1 + 1? Yeah, that one right there.
Not currently. I have in the past, but there have been very few students that wanted to take it, and we have to, especially if we're making a new section of the class, not like it's already made already, we're just trying to fill it. We need at least 15 students that say that they want to take it in order for us to actually do it. But it
I'm
is
really
possible.
proud of you.
This is AP Physics A or AP.
Oh.
No, actually, this is AP Physics 1.
I'm just trying to go UCLA.
So it used to be before AP Physics 1 and 2 occurred back in 2015. It used to be AP Physics B. So B was the algebra-based class, C was the calculus-based class. But then they changed it, they disbanded B, and then they made two classes that are AP Physics 1 and AP Physics 2 now. But they still have the C class.
How many years until the C class?
I like
How many
that. I enjoy
Like,
that. I
like
just
how
hate
many,
this.
like,
Are you gonna take AI
how
or
many
AA?
classes of physics do you have to take to get to the C?
I'm taking AA.
So
HL.
technically, so AP Physics 1, the class that we're in right now, although we're also doing the IB Physics Year 1 along with it, okay? It is designed as a first year
Did
course.
you take in high school? Yeah.
The AP Physics C is not designed as a first year course,
Yeah,
so you
I was
definitely
about
have to
that.
have 1 year of physics,
Just one
either
question.
honors or AP 1,
That'd be like a
before you
good
can be able to handle APC. Because we don't start from scratch, we are assuming that you know some basic physics stuff, and then we just do harder stuff aside from that, so, which is cool.
Is HL calculus based?
No, actually, sadly, it is not.
It's
Yeah.
algebra?
Huh?
It's algebra based?
Yeah.
Yay!
I,
It's easy.
I,
I love
I
it.
have,
I might take
I
extra
have,
credit.
I have long questioned why
But-
the IB physics isn't calculus based, but I kind of know the reasons because IB physics, especially if you're going HL, but here at Paxton, it's 2 years regardless. But you would have to, ideally, in order for the student to have the best possible chance for success, the student should have taken calculus already before entering the calculus-based physics, which means you would need to have taken calculus as a sophomore in order for you to be prepared mathematically for a calculus-based IB physics for both years.
Do we even?
And
Do we even?
there's not a
offer
whole lot of
calculus
students that are in that boat.
Algebra? For sophomore?
Not impossible, but
Just give calculus.
few.
We
You
could
gotta
have
find an app.
I think that's why the IB chose to keep physics just algebra-based and instead of having some calculus in there as well.
So C is your favorite class, AP Physics C.
C is definitely the funnest class that I have taught.
For you.
That I have taught.
I'm not gonna
Taught.
IB Physics.
Have taught.
I don't want to get a B every single
Yeah.
time.
Had taught. Yeah. So C is absolutely my favorite subject to
I
teach.
took IB, yeah.
But I'm not teaching that right now, so AP Physics is definitely my jam. Yes,
We're really off topic.
I know. Let's get back on topic. Yes. Shall we? Here we go. So we've got our position as a function of time, and we've got our velocity function as a function of time. So based on how much time has passed in the oscillation, we can find out where the object is and how fast it's going. Easy peasy. The only thing that we also need to mention is as we are calculating, like let's say that we're actually calculating with our sines and cosines with our calculator, all of this stuff needs to be in radians. Okay? So unlike before, whenever we did like two-dimensional vectors and we were using our sines and cosines with our angles were always in degrees, so we had to have our calculators in degrees. For oscillations, we need to keep our calculators in radians as we calculate with our sines and cosines here. Okay? Radians. There you go.
All right.
So perfect.
Cool. Alright, so now we're going to switch gears and we're going to talk about energy. So we had touched on it before, but now here comes the equations. So here we go.
Hey, we didn't ever get up.
Say what?
No,
Okay.
Your lesson,
Yeah.
your lesson
Perfect
is like
timing.
synced up with my calculus teachers right
Now, calculus or pre-cal?
What?
Is it going?
Pre-cal, okay,
I thought it was
yeah.
fucking going.
But hey, that's good.
Yeah, I thought it was, but that was way later in the day.
That was not on purpose.
It's 2.
It was fake.
Some people stay until 3 o'clock.
A happy
I'll stay
coincidence. Yes.
Wait, so
No way you're gonna stay until 3.
I'm gonna stay until 3 today. I didn't stay until 3 last
You're
class.
IB. So, have you taken chemistry? So you have a choice between IB Bio and IB Chem if you don't choose physics.
It's okay, Mr. Meany.
Although I think for next year they're starting the IB in environmental science is updating and is joining the group 4
It's gonna be
because
easy.
before it was just a 6 subject, but I think starting next year it is officially a group 4. So you could also take IB environmental science as
That's
your
perfect,
official
dude. I'll be in
science.
a college, man.
I think that is true. Don't quote me on it.
Dang it.
I'm not exactly sure. I'd have to talk with the counselors like Baseball Pepper and stuff to be sure. But I think that was the plan because the environmental science kids are going to be joining us for the Group 4 project, not this year, but next year. So I think, yeah. So now, the IB environmental science is kind of like IB physics where you don't actually have to have a first course in order to go into it. because IB Physics is special because we're calling IB Year 1, or we're calling AP Physics 1 IB Year 1. So most of you guys have never seen physics before. This is your first time, but you're in the class if you choose to continue to do so. But for bio, I mean, you guys all take bio. That's a state requirement, so that's always an option. But chemistry, IB chemistry, they don't start from scratch, and so you definitely need a first-year course in chemistry in order to do well in IB Chem.
Chemistry was so good.
Good. Cool. All right, so let's talk about energy. So as I stretch the spring, before I let go, I've given it spring potential energy, right? And we saw some graphs last class about how, although we start off with some amount of the potential, as I let it go, as it starts to oscillate, we've got the potential and the kinetic, and they go back and forth. And we saw those graphs that weren't actually lines, but they were curves, as we see them changing throughout the oscillation. So let's take a look at our initial amount of energy here. So we know that we're going to have it conserved, so the energy initial is equal to energy final. But let's start off with our initial, okay? So my initial is all spring potential. Remember, that's going to be way back in A3. A3, if we switch back to the A3 page, our Hooke's law equation, which is our spring potential energy equation, is going to be our 1/2 kx squared. Now, this isn't just any displacement though, because we're talking about the initial spring potential energy, that x actually is the amplitude, which in those equations we actually called x naught. So in terms of my initial, I'm going to say that it starts off with a 1/2 kx naught squared, okay? And let's just jump into, well, that's really our E total, okay? Because it's going to be conserved, if we only start with that, that number is going to be the same throughout as it switches from potential to kinetic, but the total remains the same number like we saw in that graph the other day. Okay, now, in your equation sheets, let's go back to C1, AHL. The ET, although it looks kind of different. It doesn't have K in it. It has M, and it has the omega squared in it. So remember that there was a relationship, so our period of the mass on a spring, remember 2 pi square root of M over K. But in general, the period was equal to 2 pi over the angular frequency. So in this case, we're going to set them equal to each other because I'm trying to substitute out the K. Okay? Okay. All right, so solving for K, 2 pi's cancel. I'm going to flip both sides because the K is on the bottom. So now the K is on top. Square root of K over M is equal to omega. We're going to square both sides. And we're going to multiply both sides by M. So now we've got an expression for K. We're going to substitute in here, and we get 1/2 M omega squared x naught squared. And this is our total energy equation that they give us in the equation sheet. Yeah, look at that. That's cool. So again, this is specifically for a mass on a spring because it has mass in it. This is not for pendulum, just for mass on a spring. Okay, well now we know how much total we have. We know that at any particular point in the path, the total is going to be equal to some potential and some kinetic. But the sum of it, as we add them together, they always have to equal what we started with, because we're going to assume that we're on a smooth surface, no friction, so we're going to conserve the energy. Okay, so if we say that, all right, well, our E total is going to be equal to our E potential plus our E kinetic. That's fair to say. And our E potential, well, oh, look, they give us a new equation for the E potential. Although it should be our Hooke's law equation. Remember, it was 1/2 kx squared. In this case, at any particular position, so not necessarily at the amplitude, but at any position, it's got that amount of potential energy here. So we are going to use the same substitution to find our new potential. So our EP is going to be 1/2 m omega squared x squared. So it looks very similar to this one, except this one is the total because it's based on the amplitude, which is the maximum displacement, and this one is at any particular position we so choose, how much potential energy it has. Okay, so this is going to be our next equation, and last but not least, we are going to use the concept of conservation to come up with or derive an equation for the velocity as a function of position. All right, so here we go. So our ET,
Find an equation for velocity as a function of position.
do you guys even know what ET is?
Yeah.
Okay. All right. Have you seen ET? I actually have never seen ET.
Me neither.
Yeah. I don't know. Like, I'm a kid from the 80s, so I should have seen it. My parents were sci-fi geeks, so, but I don't know why I never saw ET.
It's not that interesting.
Sci-fi movies, like my grandparents.
Right.
Well,
The universal right.
so I think it might have to do with when Star Trek originally started.
Yeah.
It was a show in the 60s, and that's when a lot
Star
of
Trek is so long.
Too much stuff.
my parents, y'all's grandparents, were growing up as a kid, and so that sparked their sci-fi-ness, and then it just kind of stuck.
Star Trek is